Starting from the mid of the 20th century, the NASA and many other organizations managing complex projects introduced and continuously improved the so-called stage gate methodology for project management. According to this approach, the project is divided into rigidly sequential phases. At the end of each of them, there is a decision gate, where it is possible to decide whether to continue with the project or abandon it, also called go-kill gates. Every organization can identify specific phases according to the nature of the project. But in 1990, Cooper defined a basic structure applicable to almost all the innovation projects, where the stages are preliminary assessment, business case preparation, development, testing and validation, and finally, full production and market launch. This management model builds on the assumption that decisions made in every stage should be not changed in the following ones. For this reason, in some environments like software development, this methodology is also called waterfall, to stress that once the water went from one stage to another, it cannot come backward. This project management methodology strongly relies on the front-loading strategy. According to the front-loading principle, it is appropriate to reduce the project uncertainty in its initial phases. Lowering this curve will lead to two possible results: making decisions at the same time but with lower level of uncertainty, or, even more important, enabling the identification of required changes earlier, allowing to introduce them at a lower cost. To effectively pursue the front-loading, it is possible to act on three different elements: applying shared and standard techniques for planning and controlling, involve the stakeholders, and anticipate the creation of knowledge. For the sake of simplicity, we will not further investigate the first element in this lesson, as we will dedicate many classes to it later on. Regarding the stakeholders' involvement, we can act on two aspects: the project team's composition and the anticipation of the stakeholders' involvement. Regarding the first point, we all know that having a multifunctional team is a best practice. Mixing different functions allows to have more variety of knowledge, approaches, and points of view on the project, and therefore increases the probability of making better and more thoughtful decisions. In many cases, it is useless to have many people with the same skills, goals, and experiences, because they would provide an homogeneous and uniform vision of the project, which could be short-sighted and partial. On the other hand, regarding the right moment to involve stakeholders, it is essential to say that it is appropriate to anticipate as much as possible their involvement. This will not always be easy, because projects, by their nature, often require the intervention of more functions and skills, but at different points in time. For example, let's think about the project for developing a new dialysis equipment. We will need different competencies for this project. First, we need to identify and test the technology, then to design the equipment and the production process, to test and verify the equipment, to sell it to the market, and train both the users, the maintenance, and the post-sales service providers. Technicians who will maintain the equipment in the future might experience some problems from the design. Nurses, using the equipment daily, might have suggestions about incremental changes to improve them. Unfortunately, these actors intervene only at the advanced stage of the project, when design inputs coming from their experience would require a too expensive change to the project. In many cases, their knowledge was already accessible in the early stages of the project, but no one cared to look for it and collect it. Many project management best practices are based on the early involvement of stakeholders. For example, in the software development industry, the end user is involved from the initial stages to direct the design and reduce its inertia to the change once the application is released. Similarly, in the automotive and white goods industries, the distribution network, the after-sales department, and the repair services are involved from the beginning to reduce the total cost of a product during the entire life cycle, not just its design and production cost. The third element we can leverage to pursue the front-loading is knowledge. Also in the case of knowledge, we can identify two different aspects. On the one hand, the reuse of existing knowledge, and on the other hand, the creation of new knowledge. Even if projects are unique activities, they can leverage previous knowledge developed in past similar projects. In some cases, this experience is already embedded into company procedures, for example, designed to cost rules or designed for assembly rules. More often, though, it is in a tacit form, safely stored into people's memory. This explains why it is essential to reuse knowledge in the initial stage of a project to involve the right stakeholders in the early project phases. The generation of new knowledge, instead, requires to be managed and targeted more precisely. In some cases, the project's problems are truly unique, and it is not possible to reuse any past experience, simply because there's not a past experience. In these cases, it will be necessary to develop new tests and experiments. It is important to understand that in a project we can have different typologies of tests. Let's consider, for example, the crash test used when developing a new car. An interesting question could be, according to you, is the crash test a useful tool for the management of a car development project? The answer, perhaps counterintuitive, is no. Obviously, no one is saying that the crash test is not useful to develop a car. It is mandatory by law, but it is not useful to manage the car development project. This is because, as you could see, the test is performed on existing and completed vehicles. This is a validating test, performed at the end to validate the work already done, and not an explorative one, focused on generating new knowledge to be reused during the project. However, it is possible to perform exploratory crash tests in initial phases of a project, when the knowledge created can still be used without implying a high cost change. To do this, we need to use advanced technologies. But even more important, we need to change the mindset and the reason why we do a test. For many years now, cars have been tested in virtual crash tests, carried out in the project's initial phases, when it is still possible to intervene with significant changes to architectures and without suffering high cost and delays for the implementation of these changes. To conclude, we saw that the stage gate approach could be pursued through planning and control methodologies, involving the right stakeholders at the right time, and finally, leveraging on existing knowledge if we have it, or generating a new one if it is needed.